The universe is slightly hotter than it should be. Dark photons could be to blame. Intergalactic gas clouds are slightly hotter than they should be, new research claims, and theoretical particles called dark photons could explain it. Observations suggest that the intergalactic gas in our universe is a little hotter than it should be. Recently, a team of astrophysicists have used sophisticated computer simulations to propose a radical solution. An exotic form of dark matter known as dark photons could be heating the place up. These strange particles would be the carriers of a new, fifth force of nature that normal matter does not experience, but occasionally these dark photons can flip their identities to become regular photons, providing a source of heat. Feeling neutral, we could find such dark photons by observing the intergalactic gas using what's known as the Lyman alpha forest. Here's why. That light has to filter through billions of light-years of gas to reach us. When astronomers look at the light coming from that object, it will look otherwise unremarkable except for a gap at the wavelength of that specific energy transition, known as the Lyman alpha line. The light from the distant object will pass through multiple clouds and clumps of neutral hydrogen. These Lyman alpha gaps can also be used to measure the temperature of each gas cloud. If the neutral hydrogen were perfectly still, the gap would appear as an incredibly thin line. But if the individual molecules are moving, then the gap will widen because of the kinetic energy of those molecules. The hotter the gas, the more kinetic energy the molecules have, and the wider the gap. In a paper appearing in November in the journal Physical Review Letters, a team of astrophysicists have pointed out that by using this method, it seems that the clouds of gas that scatter between galaxies are a little too hot. Computer simulations of the evolution of those gas clouds predict them to be just a little bit colder than we observe, and so perhaps something is heating up those clouds that isn't currently accounted for in our astrophysical simulations. One possible explanation for this discrepancy is the presence of dark photons in our universe, the study authors claim. This is a very hypothetical form of dark matter, the mysterious, invisible substance that accounts for roughly 80% of all the mass in the universe, yet doesn't seem to interact with